Question 7a from the practice test. Here we have 3x plus 9 all over 5x equals 6. Trying to get x on its own, of course. Now, if x appears in the denominator of any equation, the best thing to do to start with is multiply through by that. In this case, might as well multiply through by the 5 as well. So here I'm going to multiply through by 5x, and that is going to give me 3x plus 9 on the left, and 6 times 5x would be 30x. So x is now appearing on both sides of an equation, fairly simple linear equation now. Clearly we need to collect the like terms, so subtract the 3x, leaving 9 on the left and 27x on the right. Finally then divide through by the 27. So we have 9 over 27 equals x. Well, first of all, it's nice to have the x on the left. When we do that as well, it's also nice to simplify the 9 over 27 down to 1 over 3. Question 7b. Here we're looking to solve x squared minus 4x minus 21 equals 0, and we're going to look to try and factorise the x squared minus 4x minus 21 to help us. So, put my brackets ready. It's simply an x squared, so we're going to have just an x at the front of both brackets there. And we want the numbers at the end to multiply to give 21, multiply to give minus 21 should I say, and add to give the minus 4. So 7 and 3 are looking promising. They've got a difference of 4. So if we put the 7 there and the 3 there. Now clearly to get the minus 4x, we want the 7 to be more negative. We want the big number to be negative. So we want the 7 to be negative, and the 3 to be positive there. Okay. So, and if you're at all worried that you might have got it wrong, as in an earlier question, just multiply the brackets back out again. So you would have x times x, x squared, 3 times x plus 3x, minus 7 times x, minus 7x, and 3 times minus 7 is minus 21. In the middle term then, the 3x minus 7x is minus 4x. So we've got x squared minus 4x minus 21 as we should have had, given where it's come from. Okay, so then x plus 3 times x minus 7 equals 0. So either x plus 3 equals 0 or x minus 7 equals 0. Well, if this is true, then x equals minus 3. And if this is true, then x equals 7. And there are two answers. Question 7c, looking here to solve 3x squared plus 14x minus 5 equals 0. And as with 7b, we're going to look to factorise that quadratic first. Okay. Now we've got 3x squared. Well, 3 is a prime number, so it can only split into a 3 and a 1. So the 3x squared is going to have to split into 3x and x. 5 is also a prime number, so that can only split into 1 and 5. One of those two numbers will be multiplied by the 3, and then there's the other number, and overall we're looking at 14 in the middle. So if we can get the 5 to multiply by the 3, that's going to give us a 15x there. The other one will be multiplied by that 1x, and so if you could effectively take that away, then we've got a 14x overall. We want the 14x to be positive, so in general we want the big number to be the positive, so we've put the plus there. We've got 3x times positive 5 to make positive 15x. But to get the negative 5, one of them has to be negative, and then put the negative there. We also get the minus 1x in the middle, so 15x minus 1x will give us the 14x we need. Minus 1 times 5 gets us the minus 5 we need as well. Okie doke. Now on to stating the solutions to that then. So we have either 3x minus 1 equals 0 or x plus 5 equals 0. Well, if 3x minus 1 equals 0, then 3x equals 1 and x equals 1/3. And if x plus 5 equals 0, then x equals a minus 5. So there are two answers for that question. Question 7D, and this is our first simultaneous equations question. The method here, the way the equations are set out with the x's and the y's on top of each other, presents itself as a simultaneous equations question by elimination, a method that you'd be familiar with from GCSE. So here we're looking to try and get the same number of x's or the same number of y's in each equation. So if you look at the number of y's, for example, we've got 4y in the first equation, 2y in the second, or negative 2y, strictly speaking, in the second. So if we multiply the whole of the second equation by 2, then we're going to get a negative 4y there. So let's rewrite our equations. So the first one hasn't changed. The second one, the whole thing's been multiplied by 2, so that's going to become 6x minus 4y equals 9. Now, if we call the top equation there equation 1 and the bottom equation equation 2, if we add the two equations together, these 4y's are actually going to cancel out, because we're going to have a 4y plus a negative 4y, and that will then cancel out to 0, effectively 0 y's. So 1 plus 2 will mean 12x plus 6x, which is 18x. 4y plus negative 4y, well, that's just 4y minus 4y, which is 0, so that disappears. And then negative 3 plus 9 is 6. So effectively we have 18x equals 6. If we divide through by 18, we get x equals 6 over 18, or 1/3. Now x might be 1/3, but then when x is 1/3, what is y? So to find that out, we're going to put the 1/3 back into either of the original equations. Because the second one's got a 4.5 in it, I might decide to use the first one. For example, it doesn't matter though. So, but let's say we're going to use the first one. So 12x plus 4y equals minus 3, and now we have x equals 1/3. Well, those two facts together mean that 12 times by 1/3 plus 4y equals minus 3. Okay, let's simplify this. So 12 times a third, that's a third of 12, which is 4. Take that 4 across to make minus 7, and then divide 3 by this 4 to get minus 7/4. So we seem to have then a third for x and minus 7/4 for y. Now you may not be totally confident about those. There's quite a lot of working out involved there. So a way to check that would be to put those both back into the other equation, the one you didn't use at the end. So the one we did use was the 12x plus 4y equals minus 3. So the one we didn't use was the 3x minus 2y equals 4.5. So let's put the 1/3 and the minus 7/4 back into that second equation. So we have 3x minus 2y equals 4.5. We also have x equals a third, and we also have y equals minus 7/4. So those three facts together should mean that 3 times a third minus 2 times negative 7/4 should equal 4.5. So let's see, 3 times a third, well that's a third of 3, which is 1. Minus 2 times by minus 7/4, well that's going to be a plus. The 2 can be presented as 2 over 1 if you're unsure there, and 7 over 4. So if you present the 2 as a 2 over 1, then the multiplication by the 7 over 4 becomes quite straightforward. So you've got 14 over 4. Fourteen over 4 cancels down to 7 over 2. And 7 over 2 as a decimal is 3.5. So we get 1 plus 3.5 equals 4.5. Well, clearly that's correct, and we can be sure that our two answers of x equals 1/3 and y equals negative 7/4 is correct. Question 7e, Another simultaneous equations question, but this time lined up slightly differently. First of all, the 15 is on the left hand side here rather than the right hand side, but that's a minor point. It could easily be moved across. Even if it was moved across, notice that the bottom equation here has got an x squared term in it, and the top equation doesn't. And the bottom equation has an xy term in it, and the top equation again doesn't. It's only got a y term, not an xy term. So the terms, the algebraic terms in each of the two equations are quite different. We've got an x and a y in the top term, top equation, and we've got an x squared and an xy term in the bottom equation. Now this means that we cannot use the elimination method that we did in part D. Instead, we need to use the substitution method, and the substitution method is the most important method of all in simultaneous equations, and you'll use it on a very, very regular basis throughout A level. Okay, the key here then is to rearrange one of the equations and substitute it into the other equation. Now y, notice here, appears just the once in the second equation, so if we can rearrange the first equation to make y the subject of it, then we can then substitute whatever expression we get here into here, creating an equation purely in terms of x. So equation 1 then, 4x plus y equals 2. Move the 4x across and we get y equals 2 minus 4x. Okay, and I'm now going to call that my equation number 1. And I'm going to call this my equation number 2. And what I'm now going to do is substitute equation 1 into equation 2. So equation 2 is 3x squared plus x times y, but now y we are going to take from equation 1, which is 2 minus 4x. Okay, then carry on with the plus 15 equals 0. Okay, we were left with then a quadratic, because we've got an x squared, so a quadratic equation purely in terms of x. So when we multiply out this bracket here and tidy it up, what we'll probably find is we've got a relatively simple quadratic to solve. Okay, so 3x squared plus x times 2 is 2x, plus x times minus 4x, so minus 4x squared. Copy down the plus 15 equals 0. Tidy this up a bit. 3x squared minus 4x squared is minus 1x squared, plus 2x plus 15 equals 0. Now this leaves a quadratic equation, sure enough, but it leaves a quadratic equation with a negative x squared term, and that's a little bit tricky. So the easiest thing to do here is to either multiply 3 by minus 1, that'll do the job, or we can effectively take all the terms to the other side. However you look at it, let's say we're going to multiply the whole thing by minus 1. What happens is the sign of each term switches. So minus x squared times minus 1 would be positive, positive 2x would become negative, positive 15 becomes negative, and 0 doesn't change. So x squared minus 2x minus 15 equals 0 is a much more straightforward equation to solve than the minus x squared plus 2x plus 15 equals 0. So now we're going to look to factorise. X squared is just, there's only one of them, so an x and an x at the front of the brackets there. 15, well 3 times 5 makes 15, and the difference of 3 and 5 is 2, so that's looking very promising. We want the 2x to be negative, so therefore we want the biggest number to be negative to effectively win. And the other one has to be positive, so this way that we get the positive 3 times the minus 5 to make minus 15. We get minus 5x times and then plus 3x, so minus 5x plus 3x will simplify down to minus 2x there. And remember, you can do a quick check at the side of the page if you so wish. Okay, so if we have x plus 3 times x minus 5 equals 0, then either x plus 3 equals 0, or we have x minus 5 equals 0. If x plus 3 equals 0, then x equals minus 3. And if x minus 5 equals 0, then x equals 5. So, two answers. Now, the danger here is that we stop there because we've just solved a quadratic equation, and that in itself is often might be a question in itself. And we think we've got our two answers, so we'll stop there. But if you look right back to the start again, the equations don't involve just x, they involve x and y. We rearranged to make y the subject of this and substituted it in. So our answers need to involve not just x, we also need to involve y as well. So for each of these two x values, we are going to find the corresponding y value, and we're going to do that by substituting in the relevant x value into this red equation up here, which is a rearranged first equation. So we had the y as the subject, so y equals 2 minus 4x. If now I'm saying that x equals minus 3, then the y value at that stage would be 2 minus 4 times minus 3. Minus 4 times minus 3 is plus 12. So I get 14 for that one. Similarly, when x equals 5, substitute it in to the y equals 2 minus 4x equation. And minus 4 times 5 is minus 20, so this time 2 minus 20 is minus 18. Okay, so we now have pairs of equations. So our pairs of equations are, pairs of solutions rather. Our pairs of solutions are x equals minus 3 and y equals 14. And we also have x equals 5 and y equals minus 18. That is now our final answer. If you wanted to do a quick check, you could substitute each pair of solutions into one of the first two equations, probably the 4x plus y equals 2, and to check that they both satisfy that equation. But for that question, I'm going to stop there. Question 7f, and here we're looking to solve a cubic equation, but where every term has got a common factor of x in it, and effectively that means that this is really a disguised quadratic, and the disguised quadratics crop up a lot in A-level maths in all sorts of different contexts. So here, to see that more clearly, if we factor out that common factor of x, we have x and then times by 5x squared would be then 5x cubed there. X times by 19x would give us the 19x squared. X times by minus 4 would give us minus 4x. That equals 0. So you can see there we've got x times by a quadratic equals 0. Now then, if we can factorise that quadratic in the normal kind of way into two brackets, what we end up with then is actually three factors. The two brackets as normal, plus the third factor, which is the x on the outside there. And what you must never be tempted to do is to divide through by x, because by dividing through by x you will lose one of the answers. You'd effectively divide away one of your answers. So we need to keep it there. Okay, let's look to see if we can factorise 5x squared plus 19x minus 4. Well, 5 being a prime number means that it has to be 5x and x at the front of the brackets. Minus 4, well, that could either be 2 and 2. Now, if it was 2 and 2, then the 2 here would get multiplied by the 5 to make 10, and the 2 here would go with that to x. So you'd be looking at, say, either 12x or perhaps 8x if it was a subtraction. That's not particularly helpful to get towards 19x. If it's 4 and 1, to get towards 19x, well, 4 times by the 5 would make 20x, and then 1 times by x would make 1x. 20x minus 1x is the 19x, so that's looking very promising. So let's go with that then. So put the 4 there and the 1 there. 4 times 1 makes the 4. Now one of them has to be minus, and one of them has to be plus to make their minus 4. However, we want the positive one to be big, so we get the positive 19x overall. So we want that to be positive, so positive 4 times 5x makes the positive 20x. Now this one could be the negative, so that minus 1x there, so you get 20x minus the 1x gets you back to the 19x. Okay, so at that stage then we have the three factors now. The first factor then is x, so if x equals 0, everything would equal 0, so that's one solution. If 5x minus 1 equals 0, then everything would equal 0. And if x plus 4 equals 0, then everything will equal 0. So x equals 0 is a solution in itself. 5x minus 1, well, that will simply rearrange, add the 1, divide by 5 to get x equals 1/5. And x plus 4 equals 0, that will rearrange to get x equals minus 4. So this time notice that we had, it's a cubic equation with an x cubed term in it as the highest power. The highest power of x being 3 there, and sure enough we end up with 3 different solutions. A little rule of thumb there, that in general you get the same number of solutions as the highest power of x. There are exceptions, but that is a sort of a rough rule of thumb to go by. Okay, and then we'll finish there.